Altimeter show altitude above mean sea level MSL. Altimeter show altitude above mean sea level MSL. Attitude indicator show orientation of aircraft relative to horizon. Turn coordinator displays aircraft roll movement. Airspeed indicator show aircraft airspeed. Digital clock displays the current Zulu time. Fuel quantity display how much fuel your aircraft has on board. Fuel flow display amount of fuel being used in gallons per hour. Vacuum gauge ammeter displays the pressure generated by vacuum pump. Engine oil indicators displays engine oil and temperature. Directional gyro displays the direction your aircraft is going. Vertical speed indicator displays how fast you are climbing or descending in 100 feet per minute. For receiver with glide slope display glide slope and localizer needles for ILS approaches. Or receiver measures the bearing from the selected VOR station. ADF bearing indicator points towards selected heading from nav system page. Tachometer displays the engine's revolutions per minute RPM. Electronic communications navigation box. Mixture controls how much fuel gets injected into engine. Throttle gives power to engine. Pitch trim is rotated in the direction that you want the airplane nose to move. Fuel shutoff, pull the lever out to stop fuel delivery to the engine. Alt static air, alternate source of static air for the instruments. Tachometer parking brake used when we don't want to push the right left foot on the rudder's brake pedal. Ignition switch provides a spark to master switch, turns on off electrical system. Parking brake used when we don't want to push the right left. Emergency locator transmitters else has a 3-position switch on. The standard airplane is composed of the fuselage, the wings, the empennage, the landing gear, and the power plant, but there are a lot more components involved. This aircraft has a tricycle landing gear, and it is fixed, meaning that the pilot won't have to worry about it during takeoff and landing. The front wheel is controlled by the pedals to steer on the ground. The back wheels have brakes that can be actuated independently by use in the pedals. This can help control the direction on the ground and, of course, slow down after landing. The power plant includes the engine, propeller, and other components. The engine not only rotates the propeller to generate thrust, it also moves the alternator to produce electricity, a vacuum pump to maintain gyroscopic instruments working. The airplane has a fuel tank on each wing. Each tank can store up to 28 gallons for a total of 56 gallons, or 211 liters. The fuel used in this aircraft is the 100 low-lead grade aviation, which is blue in color. There is a small fuel reservoir to catch the fuel from a return line from the engine. An electric auxiliary fuel pump is used to prime the engine during the startup. The control surfaces are used to maneuver the aircraft. The primary control surfaces that you will find in all airplanes are the ailerons, the elevator, and the rudder. The ailerons are on the wings. They control the roll of the airplane. The ailerons are controlled by wires connected to the main control hub, where the yokes are also connected, which, similar to a steering wheel of a car, they will move to ailerons and in turn the airplane to the desired direction. The elevator uses the same mechanisms of wires to be controlled from the yokes, where they are linked to the elevator. If you push the yoke, that will lower the elevator, pitching the aircraft down, and if you pull on it, the opposite happens. The rudder is controlled with the pedals to go to the left and right. This motion is called yaw. The yaw rotation happens in the vertical axis. The flaps are used to slow down the aircraft and generate more lift at lower speeds. These devices are mostly used during takeoff and landings. Flaps can only go down as opposed to the ailerons that move up and down. They can lower in steps of 10, 20 and 30 degree. Flaps can only be used in a safe range of speeds. The cockpit is also where you'll find all the instruments and control of the aircraft. In the instrument panel, we can use the primary flight display and the multifunction display. Rotate the fuel selector to both. Set the fuel cutoff to forward position. Turn on battery master switch. Turn on fuel pump. Turn on beacon light. Set parking brake by pull and then rotate move the mixture lever to forward position. Move the throttle lever forward slightly, about 10. Rotate the magneto key to start and hold it for 5 sec. Turn off fuel pump. Turn on avionics master switch. Rotate clockwise and push back to release parking brake. Set parking brake by pull and then rotate anti-clockwise. Set wing flag position to up position. Adjust pitch trim at takeoff position. Rotate clockwise and push back to release parking. Pull the yoke when the aircraft reaches a speed of 73 knots.
Cyclic.
Controls the helicopter.
Cyclic.
Controls the helicopter's attitude and direction of flight.
Collective control.
Adjusts the pitch of the rotor blades collectively.
Pedal.
Control the helicopter's tail rotor, which adjusting yaw. Electronics, communication, and navigation box. Vent. Allowing the pilot to control the amount of vent. Allowing the pilot to vent.
Fuel.
Dual fuel valve. Switch is used to select between fuel valve. Outside air temperature, show ambient air temperature. Caution panel. Provides visual alerts of various systems. Engine oil. Torque percent. Airspeed indicator. Attitude indicator. Altimeter. Show altimeter. Transmission oil. Turbine outlet temperature. Fuel quantity. Gas generator RPM. Fuel flow. Digital clock. Glide slope indicator. Shows helicopter descent path alignment. Turn coordinator. Show helicopter roll movement. Dual tachometer. Show the main rotor RPM and the power turbine RPM. Directional gyro. Fuel
Cyclic.
collective control. Adjusts the pitch. The standard helicopters is composed of the airframe, the fuselage, the main rotor, the tail rotor, the landing gear, and the power plant. But there are a lot more components involved. The airframe is made of aluminum and aluminium composite materials, as are the outer panels or skin. The airframe and skin is lightweight but strong enough to support both the engine and main rotor with associated components, which take up the entire area above passenger, crew, and cargo areas. Fuselage houses the cockpit, cabin, and other components. The fuselage is constructed primarily of aluminum alloy, with the cabin area designed to accommodate passengers or cargo. The tail boom is a crucial structural component that extends from the rear of the fuselage. Constructed from lightweight materials, often aluminum or composite, to balance strength and weight. It houses the tail rotor, which provides directional control. The tail boom helps stabilize the helicopter by counteracting torque produced by the main rotor. The glass windows are typically made from high-strength, shatter-resistant acrylic or polycarbonate materials to ensure durability and clarity. They provide pilots and passengers with a clear view not only to the front and sides, but also above and below the craft. The helicopter is equipped with 2 skid-type landing gear, which includes 2 long skids extending from the fuselage. The skids provide a stable platform for the helicopter during ground operations. The helicopter typically features a 2-blade rotor system, which provides a balance between performance and simplicity. Main rotor blades are constructed from lightweight composite materials to enhance strength and reduce drag. The main rotor blades create lift by rotating through the air, with their angle of attack adjusted to control flight. The tail rotor counteracts the torque generated by the main rotor, preventing the helicopter from spinning uncontrollably. It enables the pilot to control the helicopter's rotation around the vertical axis, allowing for precise directional movement. The vertical fin, also known as the vertical stabilizer, is an essential component of the helicopter's tail assembly. The vertical fin helps maintain directional stability during flight, preventing unwanted yaw movements. The horizontal stabilizer helps maintain pitch stability during flight, preventing unwanted nose-up or nose-down movements. It assists in providing a stable platform for the tail rotor and contributes to overall aerodynamic balance. The fuel tank has a total capacity of approximately 50 gallons, 189 liters, which supports extended flight durations. The tank is typically located within the fuselage, often in the lower section to maintain a low center of gravity and improve stability. The helicopter features a single turboshaft engine, which provides power to the rotor systems. The turboshaft engine gets its name because it's designed to power a mechanical shaft instead of producing thrust with a stream of jet exhaust. The engine is rated to continuously produce 650-plus horsepower. It's anchored to the roof just behind the main rotor. Toward the front, there's the cockpit, with essential gauges, navigation aids, switches and controls for the pilot, and the optional dual pilot package.
The standard drone is composed of the airframe, propellers, landing gear, and the power system. Additionally, there are a lot more components involved. Main structure. The structural backbone of the drone, holding all other components, provides support and houses other components. It determines the drone's shape, size, and aerodynamics. Electric motor. Electric motors that drive the propellers, generate lift, and enable movement. They control the drone's ascent, descent, and maneuverability. Propellers, blades attached to the motors, convert rotational motion into thrust, enabling the drone to fly. Landing gear provides a stable platform for takeoff and landing. Battery pack, the power source for the drone, supplies energy to the motors, flight controller, and other electronic systems, determines flight time. Flight controller, the brain of the drone, processes input from sensors and controls the motors to stabilize and guide the drone during flight. 3-axis gimbal stabilizes the camera during drone flight. Front camera is used to capture images and videos.